we're gonna need just a little. everybody, how you doing today? I hope you all had a great weekend. Mine actually was pretty good. A bit busy, but that's okay. It's kind of strange. At the same time, it feels long, but at the same time that it went by too quick, if that makes any sense. But that's all right. Okay, so let's get into programming right away. And we are working on the new terrain system. And I'm trying to remember exactly how far I'd gotten. Well, I guess just test it out. Okay, so we have blocks loaded in, but they're not deformed yet. Okay, and I think I had done some of the insets and stuff, but I wasn't sure. Okay, so maybe this... Oh yeah, I remember. So we were only doing the insets for just a simple case where we don't care about the neighbors, because we have to take neighbor blocks into account. Everything gets a lot more complicated. Yes, let's look here. So we have the insets, that's all good. And then put them out. Oh yeah, and then I remember we needed to change it so that the points... Yeah, I used to have a point array on every cell, but the point needs to be per block, so I decided just to use this inset data instead because it's it's really easy to get these corner points just by adding the inset to the regular points. Okay, so let me see. I guess we gotta do the deformation now. Okay, so yeah, that's model index, cliff height. So I guess we can go ahead and generate the meshes, and then we'll need to maybe have a different object or a different class that will deform them. So let me see. Also, every block won't necessarily have a mesh, so... Okay, so what am I trying to do? Oh yeah, so this terrain data, I just need to add mesh. And then here we'll just have a public mesh. Of course, some of these won't necessarily have a mesh associated with them. Also, okay, so we're gonna need the actual game object for this, because that would have like the renderer and things. So yeah, that's fine. Okay, I guess I'll just make a new class. Or do I already have one? I already have the model creator. Oh, I already had this model mesh, so I guess I don't need that. We'll just have something else for the deformer. So yeah, I really just need to modify this class a little bit. Yeah, so it's waiting for the model index, which is all it needs. But it also will need the cliff face, because we can, by looking at the cliff heights, we can see if certain meshes do not need to be created because they'd be hidden. Okay, so this private, static, cell tasks, dependencies. So we need the model index and the cliff heights. Okay, and so here we're checking to see if this complete contains all flags that we set dependencies. And instead of checking that doesn't equal 0, since we have more than one dependency, we have to make sure that it equals dependencies. Okay, so here we just create everything, which is fine. So I want to store the game object in this block. So block dot equals game object, and then I also need to create a copy of the mesh because we're gonna deform it. Probably. I'm trying to think, like, would it be worth it to try and see if certain blocks would still have the same mesh and try and share them. I think the possibility of that happening is pretty low, so. So, let me see. I think I just did another instantiate. What am I looking for? Okay, so I just instantiate the mesh. Yeah, so first I instantiate the game object and then I get a mesh out of it. Okay, well, I think we'll make it work like this for now. But later on we might want to support multiple different meshes on a terrain block. Okay, so and then we set this new copy there and then add the mesh to the block. And if we didn't do this, when we deform the mesh, it would be shared between all objects with the same model, which we don't really want to do because the deformations depend on where the block is placed. Another way to do this is still have everything share the same mesh, but instead do the deformations in a shader. And I keep going back and forth about which one would be better. This way, well, in theory, we save time because I pre-calculate all the points, but we'd have to upload all this mesh data to this shader every time anyway, so I'm not sure which one would actually be faster. I think well, whenever we get to the optimization phase, we can see about doing that. Because I think this is something we could do in the shader. But anyway, this looks good. Okay, so I guess let's make sure that there's no bugs in this code. Okay, yeah, so everything's still there. Alright, so let's try and do some deformations now. So I guess I'll just have a model deformer class. We could have a separate class that figures out, because how I did it here was first, okay, well there's something called a barycentric coordinate, which is kind of, okay, well, let me bring up my diagram. It's hard to explain, but it's like you have a triangle and you take a point and you can define that point as a combination of any of the 3 points of the triangle. And the barycentric coordinate basically just tells you the multiplier of those points that you need to add together to get that triangle. So for example here, this point is in the middle of this triangle, so that means it's the barycentric coordinates is 1/3, 1/3, 1/3. But if you put it here, then it's 1, 0, 0, 0, 1, 0. Then this would be 0, 1/2, 1/2, for example. So we basically want to calculate the barycentric coordinates for every point on the mesh, taking the hexagon wedges as the triangle. And doing that, we can, when we deform these points, this point will also be able to be moved along with the triangle. So, for example, I could figure out the barycentric coordinates in a separate class, but I don't think any other part of the mesh generation is going to need it, so I don't really think it'd be worth it. But I guess another question is, where do I store the barycentric coordinates? Well, I guess I don't really have to store it. We would just figure out the barycentric coordinates and then transform it immediately. That's what I do here. Okay, yeah, so this is figuring out the insets, which we did do already. Alright, so I'm going to use this as a base. But actually, I don't think we'll need anything else besides the terrain, because everything else is given to us. Sorry if my voice is a bit scratchy today. The allergies have been bad lately. But, okay, so yeah, we won't need that stuff. Okay, so the dependencies for this, I guess we just need the model mesh, and we need the cliff heights, and then we need the insets. Okay, and then we'll need to do something else, so I guess I'll just call this deformed. Oh yeah, and then this needs to implement by ticking, which it says it has this tick method to be called every frame. Alright. So first I just need to, I guess I just have to loop through every point in the mesh. Okay, so what I'll first do, let's see. Okay, no, I guess I'll need to know the index. So for each layer, layers less than cell, stack, length. Let's spin this off into another method, I think. Okay, and so if block dot mesh does not equal null, then we'll actually let's do it this way. So if it does equal null, we'll just exit now, because there's no mesh to deform. Okay, so now what I need to do is have a list. Okay, so I have to deform the points and then the normals. Everything else can stay the same, but trying to think. Yeah, the normals will be a bit difficult. We'll have to figure out some math, because it's like, I'm doing something with my hand, but when you change. So we're gonna basically deform the slope to be like this. So I have to somehow get the normal to stay perpendicular to the surface. Which is definitely possible. We'll have to figure out the math. Let me see. So I guess let's just not worry about the normals yet. But I will need a temporary list for... Or no, will I? Because we already know the number of points, so... Okay, let's do mesh equals block dot mesh, and so we have to pull this point vector out. Although I think if you do this, doesn't it like generate a whole new array or something? So this might not be... Oh, I don't know if it can be helped. Well, that's okay. I mean, it's not like this is going to run very often. Okay, so for int v be less the vert's length. I can type. So here the code is you basically take every vertice and then you transform the point from the mesh's local position to world space around the object. Okay, so that's another thing. Maybe... okay. So what I really want to do is take the actual game object, because the game object will be translated and rotated. And so I want to transform the mesh to the world space for the game object, but then I need to offset it so that 0 is the center of the... 0 is the center... What am I trying to say? I guess the origin, yeah. And then I'm going to need to transform back, which before was a bit... hacky, because what I did, oh, well, not really. But I don't know. Okay, this is... kind of interesting. So I think I actually do... Yeah, I need to have this transformation for the object that contains the mesh, so that it gets the cumulative transformations for all the way up the tree. So I don't have that, which I guess I can add it. Okay, so let me see. This will be the top game object, and then I'll just need to have another one for the mesh game object. So trying to think if this, I think this will work. Because it should take into account the transforms of its parent. Let me see. Unity transform. Okay, so I have local to world matrix that transforms a point from local space to world space, so... And then I have the backwards one. I mean, but I think that does the same as this transform point. Oh, so maybe I can just use this to do... Oh, no, that won't really work. Never mind. Okay, well, it goes from local to world, so yeah, it has to take into account the parent. The opposite. Okay, so basically if you did inverse transform point, then transform point, it should just return the same value. I guess we could test that, but actually I might. Okay, so this again will be the top game object. And then the block dot model game object will be the game object attached to this mesh filter. So that this top one will be the one thing that's transformed and also rotated. Which I might go ahead and add that in because it's going to be important. Okay, so quaternion. Okay, so we'll use an Euler angle. And so we only want to rotate around the y-axis. So I can just, I don't know if I want to store this someplace else, but for now we'll just do a random range between 0 and 6 and then multiply that by 60. Okay, so that will take care of that. And I guess we'll just test to see if this works. So, vector 3 transformed as block dot mesh game object transform and then transform point. So we'll just take that. This vector 3 local. And then I'll do this inverse is block dot transform inverse transform point. Okay, and then I'll just want to print these out and hopefully local and inverse will be equal, otherwise we'll need to do something about it. Oh, yeah, and also it's not going to be very good unless I pass these two strings automatically, because otherwise the, what's it called? The number of numbers after a decimal point won't be very... It's going to round, I think, to just one decimal point, which isn't useful. Okay, so let me create this model deformer. Once it's done compiling, it should start up. There we go. Okay. Oh, yeah, it's gonna... Unless there's an infinite loop, it's gonna take a long time to get back from this, because it has to print this out for every vertice, and... Yeah, for some reason, printing to the debug log is really slow. It does set this, so... Do I have an infinite loop? Not here. Okay, there it goes. I guess let's stop it. before it does another. Okay, so it looks like they're pretty much equal. Even with rotations taken into account. Yeah, I don't see any discrepancies. Cool. That's good to see. Yeah, so yeah, we have to remember if we ever want to print something in here, it's going to not be a great idea because we'll get tons and tons and tons of debugs. Okay, so we will need this inverse eventually, but first we have to convert to barycentric coordinates. So I have that math already, so I think I'll just reuse it. Oh, right. So how do I do that? Oh, yeah. First, I have to figure out which wedge this point is part of. I forgot about that, but we can do it pretty easily. Okay, and then I want to convert to vector 2s. Do I really want to deal with that? I should probably just change all these y's to z. That way I don't have to convert back and forth between vector 2s and 3s. Okay, so we can just use this as the point that we want to test. Okay, and so this is saying that, yeah, the point A is always 0 because, yeah, this point has 0 at the origin. It really doesn't need to. This is kind of easier that way, so yeah, I think we'll just leave it like that because we could just pass in the center point. That doesn't really make much difference. This is still okay, but we have to pass in the metrics, so we actually do need the game data. And we just need to pass that because the game, we have to tell the game what length our unit is. And I want to rename this to wedge because it's not really a flat fan, it's more like a wedge of cheese. So I think that makes more sense. And yeah, these should all be vector 3s now. Okay, and this math, it's not super important that you know how it works. I don't really know specifically why it works, but all it does is transform a point in 3D Cartesian space to a point in the barycentric coordinates matching this triangle. And it has to do with matrices and their determinant. So if you're really interested, you can check out this link, which is just barycentric coordinates in Wikipedia. But let me see. So that's good, but we also need to figure out what neighbor this point is in. Oh, which I already have as part of hex position, so that makes that easy. Okay, and okay, so then the vector. So now we need to offset by the translation for the the global object because we want the center to be 0. Okay. So we'll need to remember to add this back in before we do the inverse. Okay, so var wedge equals. Why is this point in neighbor? Oh, because yeah, this is kind of a weird name. Let me. Why does this not work? Oh, okay, I must not. That must be a new variable I created. Oh yeah, I did change some of this stuff, didn't I? Okay, let me just copy this and see what's different in my version. Okay, so angle to neighbor. Okay, so the only difference I think is that, yeah, this version I didn't have to pass in the metrics, so. But just in case, I'll have this commented out. But I think all I did was just pull this logic out to this special function so that I don't have to copy it. And this is actually the same now. And then facing towards neighbor, I just use this. Okay, so yeah, I don't need to copy it because it's not any different. But I want to name... Well, I guess I use and neighbor, but let's change this like point and wedge because it makes more sense. Okay, so back to here. And so now I can find the barycentric coordinates. And then I can convert this back to Cartesian coordinates, but with the deformed points. And that's really easy. That's very simple. All you have to do is, yeah, I just multiply the point times the barycentric coordinate. It's a little more complicated here because I transform back and forth between vector 3 and vector 2. Okay, so I kind of need to disregard the y coordinate of these 3. How would I... Okay, well I guess we'll just multiply this, but then I'll need to remember to set the y coordinate to... I guess the y coordinate should just stay the same. Yeah, so the y... I'll need to remember to set that later. Maybe I should just pass that in. 3 original and barycentric. Why is it not like this? Oh. Okay, and then I guess we'll just return a new vector 3 with the applied x and y, but then we'll use the original z, or original, yeah, I said that backwards. The applied x and z, but the original y. And that's just because on the xz plane, that's where we're transforming, but the y plane we should not be affected by this at all, so, or the y direction. Okay, so then vector 3 applied, or I guess I'll just call it deformed. Okay, so let me see. To get these 3 positions, well, I guess the first one is always just vector 3, 0. And then the other ones we have to grab out of the insets, so void get deformed corner. First I'll just pass the block so I don't have to get that again. So train data. Okay, block, and then corner. Okay, so we'd want to get this. And then we want to add the inset for the block. Oh yeah, so also, yeah, we use the y coordinate to interpolate between these two. I forgot about that. Although it doesn't really matter at this case. Or yeah, it does, because the height determines whether we use the top or bottom. Okay, so let me see here. Vector 3. Oh, I was going to call it normal, but that would be kind of confusing. So let's just call it standard. Okay, and then I guess instead of passing this, I actually have to pass the whole cell. Int layer, and then also the float y. Okay, and the y needs to be normalized but to the height. Okay, so we'll just won't deal with that in this function. Okay, so vector 3 inset equals vector 3 lerp between block. Oh, right. And then we also have to take into account if this is the bottom block, what's the bottom? Okay, so if layer equals 0, then the bottom is just vector 3, 0, because there'll be no deformation. Otherwise, it's block, stack, layer -1, inset at top, corner. I don't want to normalize it. Okay, and then we always have this. Like, this should never be out of bounds, so. Okay, and then we just would return vector 3 lerp between bottom, top. Okay, so I can't apply this yet. So the float Y is really just transformed Y divided by, yeah, that's right. Divided by the height. So hex position. Oh, I don't, this doesn't have it, so. Metrics, layer height, and then I guess I should clamp between 0 and 1. Okay, so that's point A. So point B going around clockwise would be this corner, which has the same index as the wedge. So get deformed corner. Oh, I don't have the cell, so. Oh, come on. Fingers. Oh no, I pressed insert by accident. Okay, so cell, oh, I have the layer right there. Y lerp and wedge. Okay, then the next one is the corner that's clockwise, on the clockwise edge of this wedge. So that's corresponds to just adding 1 to the corner index. And then of course we have to loop around and use modulo, because if we add 1 to this and it becomes 6, then we actually need to loop back to 0. Oh yeah, and also this, I have to transform to integers. Maybe I should just do that here. Let's work with integers. No reason to have the enumerations, I don't think. Oh yeah, that should be cell. That way I won't have to cast here either. Okay, and then the next is the original position, which is transformed. And then the barycentric coordinates. Okay, so that should give us the final deformed position for this point. So I need to just store that back in the array. Oh, actually no, not yet, because I've got to convert back to local space. So first I would... Okay, let's just make another variable here. Final is deformed plus block mesh object. Oh, yeah, this shouldn't be the mesh object either. This should be the top game object, the parent. And then I need to use this inverse transform point. So final equals block mesh game object dot transform inverse transform point. And then finally I can add it back to the vertice list. Okay, so let me see if I forgot something. So first I transform the local to world space, and then I need to offset this so that 0, 0, 0 is the center of the hexagon. The lighting keeps changing. It was sunny, but I heard thunder a while ago, so I'm not sure what's going on with the weather. Okay, so anyway, we transform this so 0, 0, 0 is the center of the hexagon. And then I figure out what wedge this point is in, as well as its height interpolation. I transform it to barycentric. Then I apply the barycentric coordinates to the deformed corners to get the final deformed point. And then I just have to undo these transformations to get back to local space. Okay, and then finally down here, I just apply these vertices by calling mesh.vertices equals verts. And when I do this, it should update. And I don't have to change anything else right now, I don't think. Because we'll need to update the normals, but I'll need to figure out some math for that. I'm hoping that you can update the normals without having to actually look at the triangles. That should work. Because I can kind of like see how much I deform the surface and then maybe also deform the normal that way, but we'll see. Okay, so we got some errors. Attempted to divide by 0. Yeah, deform block 60. Get deform corner. How is this? There's no divisions. Oh, yeah, that's so silly. Modulo is basically a division, and then we take the remainder. So here was a division by 0. That should have been 6. Okay, so it's deformed all right. That's not correct, but I wonder if the insets are wrong. I don't think so, because they're not that big enough. They're not big enough for this to happen. Oh, you know what? I don't. When I interpolate between the top and the bottom, I needed to add the standard to it because these are just the offsets from the standard. So that might be all that was wrong there. Okay, well, I don't see anything super wrong. Oh yeah, you can see some slopes, especially on these, so it looks like it's working, although these are not, I don't think. That's interesting. So how come some of them got deformed but some didn't? Oh, there's a bug. I didn't see that second error. Oh, that's just because I got disconnected. Alright, so let me see. That's 0, 1, 2, 3, 4, 5, 6, 7. I guess let's check number 6. Okay, so yeah, it has 2. Oh, it says there's no inset. And it does have cliff. Yeah, it says the cliff heights are here, but the insets are wrong. I wonder why that is. Oh, I know why. It's because Okay, I confused myself, but this is actually correct. It's because the stone blocks aren't supposed to deform. Okay, so this is a little confusing. I probably should have recolored them, but in fact, I think I'll go do that now. So let's just create a material. Oh, yeah, I need to go here. So this will just be test stone. I'll just make it tune. But yeah, we won't set any texture, so it'll just be white. Let's turn specular off. And then, okay, so for stone, let's just set it, I don't know. Something like that. Okay, so let's rename this to test stone and test grass. And the only thing that'll be different is the material. Okay, so let's just put these out to make sure that it's okay. Yeah, this is too dark. Alright, so now unfortunately we'll have to rebuild the asset bundle. Not that it'll take too long, so let's just go back. Asset bundles. You know, we can look and see what's going to be in it. This will take a couple minutes, but while that's working, we can go ahead and change the mod files to test stone and test grass. Okay, still not done yet. Well, actually didn't take too long. So now I just need to change or move those files to the mod folders out of Unity's asset bundle folder, and I can just drag them. Well, I guess I'll leave those open in case we have to do that again. Okay, so now it's more obvious what's going on. The grass is deforming and then the stones are not, which is good because that's what I wanted to happen. I don't like. Okay, what I should do to test it, because I don't really have any pillars of multiple types. So like over here, I should change some of these. Like this to be grass and then dirt or something. Okay, so let's look at the... Oh, I don't have it open anymore. Oh, okay, so I'm copying the prototypes. Okay, so I'm building the lower ones here, and then I'm just adding... Okay. So the fourth quadrant, I want to just handle this myself, I guess. Okay, so that doesn't really matter that much. Let's just go 6, 6, and 1 or 2 will be grass, and then wait, I don't need that in Lua. Oh, also this should be dot prototype, and then above it I'll just put stone and see how that looks. The reason this matters is because insets are different per block, so it should happen. Oh, I forgot to increase the layer here. So yeah, what should happen is the grass will be inset, and then even though the stone has an inset of 0, it will still match the grass that was underneath it. Yeah, which it does. Okay, so that's good to see. So obviously we still need to do some work. There's a little weird things like right here. It's easier to see when you look straight down. But yeah, see, we can see this part is inset right here on the corner because it doesn't have any neighbors. But then here, because it has this one neighbor, there's no inset, so it kind of looks a little strange. And ideally what would happen is it would move inward like this while these 2 points would stay stuck together. And that's what I was thinking about doing Friday, but it turned out to be kind of complicated because I need to know my neighbor's inset because we have to make sure these points match up. And so basically we'd have to like average the inset or something. So, or maybe just take probably what I would do is actually take the less extreme inset. Oh yeah, it's really obvious right here on the grass. Yeah, that looks pretty bad. So yeah, I need to do that. But I think I might, I don't know when I do it. Oh, also, yeah, we have rotations. I guess I should check to see that the rotations are working, but I don't see any bugs with the corners, so I think in theory they work unless nothing is actually rotated. Okay, no, we can see they're rotated and the corners still match, so that's good to see. Oh, that's weird. This rotation's 420. Why? 660. Because I did random between 0 to 6 times 60, so nothing should ever be more than 360. Or wait, no, it shouldn't even be that. Okay, well, it probably does. It's just how it stores the number, I think. Unless I don't add anything to it. Oh, one other thing I should check. Oh, actually, I never did it. Here, we can not, excuse me, not instantiate meshes that are below the surface. So how would check that? For this layer, I just need to see if it's ever exposed. So how would I do that? Private bool is exposed block. Cell index int layer. So first I'll need to get this. Then if cell, and then I'll need to loop through every cliff. Okay, I guess I'll need the max, or the highest block. Oh, I already did that. Cell stack length, and so if layer is greater than or equal, or I think, how does this work? So, okay. Let's take a flat area. So the cell would be 0 on all sides, but it's also the highest block, so we'd have to check. So then, if the layer is greater than or equal highest minus cell cliff heights, then we'd return true. Okay, well, let's see how this works. If there's any holes, then I'll know I need to change something. Okay. Yeah, so something's wrong. Why? And just those center ones, though. Okay, correctly did not instantiate the one below it, but... Okay, it seems like it doesn't work on any block that's flat, like it, and has no cliffs. I thought I took care of that. Maybe that's a special case if it's flat, because we have to check the top. Yeah, so this is basically checking if the side is visible. So I need to do the top as well. Okay, so bool flat. We'll just set this to true. And then flat equals flat or cell cliff heights C. Oh, this isn't actually right either. Okay, the top, yeah. Okay, so it's obviously exposed if this is the last thing in the stack. So what I would do is if highest, or if layer equals the highest. Oh, this should actually be -1 too. Then return true. Yeah, so this tests if the top is visible. And then this is checking if the side is visible. Okay, so everything looks to be there now. What's going on? I think that's just the shadow being weird. Oops. Wait, what is going on there? Oh yeah, it is just the shadow, isn't it? It just looks very strange. It's like it's inside the block almost. It's not inside it though, is it? Hard to tell. see. Oh, I can't tell there. I mean, I don't think it is. No, because this one just goes straight down. Because it has to match both those corners. Which we do want to fix later, but I guess it's just a shadow. It just looks really strange. Okay, so I think we're making some progress. Oh yeah, and so this looks weird because you don't see the back, but I actually have a bottom on the dirt. So there should be a hole, but it's hard to see. That one. Okay, so actually it's not working because this block should not be visible. Because there's no side that's visible and the top isn't. So how did I do that? Okay, maybe this should just be if the layer is greater than highest minus cliff height. Let me try that. Okay, well first let's see if that one block is gone. And it is. And I don't see any holes, so I think that is working. Yeah. Now let's look if I zoom in. You actually, oh well, yeah, you can right here that you can see through the world. That's why we need to do that blocking mesh. That's just because I don't want these blocks to have to exactly conform to these edges. And there'll be just a view blocking mesh that's just gonna be pitch black. So yeah, that will be fine. Okay, so let me see what else, or what's the next step, I guess. Okay, so I did that. That was actually simpler than I thought it would be. Implement. Yeah, so this is maybe the next thing. Or before we do that, let's try to make the game playable again. So I should do this view blocking mesh and the collision mesh. Or yeah, the collision mesh specifically. Alright, so let's see. The collision mesh is really just going to build kind of a blanket mesh like the old system. It's going to work almost the same. And it will use these points in the block. So it'll actually be, I guess, per cell, and then we'd combine that together for the final thing. But okay, so this was actually like, I'm trying to think if I even need to what's the word I'm looking for? Have like a per cell calculation for this, because to make it the most efficient should share vertices between cells, but as we saw in the old system that was really complicated to do. So I'm thinking that maybe this should like run on the whole terrain data instead of just on this cell. Because it's not really going to be that difficult. It'll just kind of loop through every block. I'm trying to see. And somehow I'll need to keep track of what vertices need to be shared. Okay, I'm just trying to think best way to do that. Maybe, okay, maybe I should just make like a simple mesh, or basically just a list of vertices in the cell, and then it would, and then the game would somehow be able to know like where the meshes, I guess the game would know where they meet, and then it could just count up the vertices that way. Alright, okay, let's try it. Okay. So this will be like a mesh part. And we'll just need to have... So the good thing about this is that any cell will only have to share one vertice with every other shell, and it would just be the... or every other cell, and it would just be at the corners. Well, okay, no, that's not necessarily true because there's different layers. Maybe... should I even just... trying to say, should I just bite the bullet and not worry about sharing all vertices? It's going to be a little less efficient, but it's going to save a lot of headaches. I'm not sure, or even like... oh no, that would be way too difficult. I was going to say even just like build the list and then try to find and remove points or combine points that are at the same position. But that would be really difficult because then I'd shift around the triangle indexes too. Yeah, this is the same problem with like the twin vertices in the old system, which I really hated. I'm just trying to think of the best way to do it. I guess, okay, I guess how I'll have to do it is... okay, well, I got one good thing is... oh, that's not necessarily true. Let's do it this way. They'll have points, and then... tries... oh, come on. And I guess if I arrange these points so that they always kind of go in a loop around, then it'll be easy to build those triangles the same way. Although, okay. Okay, so let's see. I can see an issue because the mesh might not just be like a simple cylinder if once it starts up. Like for example, the collision mesh for this point, or this block here. Let's go in the scene, it's easier to see. Okay. This song is a bit much for me right now. Okay, so this one right here. This backing part, or this back part, wouldn't have a collision mesh, so it'd be kind of like this face, this face, this face, this face, and then this top area. So if I did it, I originally wanted to store it so that we'd have the points around this edge and then this edge, but then these two are, I guess just this one wouldn't exist. And then we'd have like an empty or an unused point in the mesh, which isn't a good idea. Alright, so, okay, this is, unfortunately kind of complicated. Maybe what I could do is just make the triangles and then we can see what points are needed. And then I can add those back together. Another way I could do it is I could think of the points on like a grid system and then use like the global point area or index for every triangle, and then when I build the final mesh I would collapse those down into a list. That might be the best way to do it if I really want to be the most efficient, which I kind of want to just to solve this problem. Okay, so let's see. This could be 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. So how this would work is I guess every hexagon has 2 unique points except this last one. So it'd be 2 times the number of columns plus 1. And then the same thing happens for this top row. So yeah, we can go around like that. So the total number of points would be the total number of rows plus 1 times the total number of columns plus 1. So that's like a 2D grid of points. And then I guess we could just use the layer size to... Okay, let's I think that might be the best way to do it. Okay, so I guess, yeah, I don't really need to store these points because the point is really just going to be... Okay, so yeah, the collision mesh, there's not going to be any interpolation points, so it'll be really easy to figure out the point because it'll just be the undeformed corner plus the inset. Yeah, so we wanted to do that interpolation and all that. So I don't think we'll need anything to figure out the points, like a separate class for that. So let's just do this. Public int collider tries. So I think I might, like, doing these collider tries will be simple. So I think I'm going to do the worker that figures out, that creates the mesh from these tries first. But I guess I'll create that task there. And it will store the finished thing here. I might go ahead and create the whole game object for this, I don't know. Okay, and well, I'm not going to worry about it, but a lot of this code we can probably reuse for the blocking mesh too, because it's going to work the same way, really. Yeah, so just build everything based on the points, but the points for the blocking mesh would be different. So yeah, I'll just worry about that later. Okay, so what's something that works? I guess So that was per cell. I want something that worked. Okay, I guess this one. That was on for the whole terrain. Just copy it. And I don't need the battle, I don't think. Although I will need the database because I'll need to know the hexagon radius. Okay, so this just needs to wait until... Come on. Okay, so... In the old system, when a per section... Or wait, what's the word? When a worker that worked on the whole terrain at once had to wait for all the sections to finish, it would loop through every section itself. I think I might have like a helper class to do that in this so I don't have to. So yeah, this would be, I guess, all collider tries. Oh, also another thing is, this should be the try owners. It'll be the same thing that does this. Because this just tells us the block ID for the triangle so that we can actually pick it with the mouse. So some other class will loop through all the cells to see if this task has been done and then set this in the train task so I don't have to do it here. That's not what I should do. The collider mesh and then private, static, train, tasks, dependencies, and we just need all collider tries actually. Okay, so again, we want to check to see if our work has not been done already, and all the dependencies are complete. Okay, so what we do here, so I need to loop through every cell and keep track of every point needed, as well as, okay, dictionary. So this will be like an integer from the global point index to the local point index for this mesh. Okay, let's go ahead and create this because I always forget to do it. And also I need to remember to clear it when I'm done. Okay, so what I do... I guess I also need a list for the triangle owners. List int. And I'll need a list vector 3 for the vert. I guess verts. The normals I don't think matter for the collider. And neither do UVs because it's not visible. Actually, I'm not sure if the normals matter. Let's look. No, we just have vertices, triangles, and the owners. So, yeah, I do need to have actually the triangle builder, so. Let's do it like that. And then builder. And then I'll just call this the owner. Okay. private void, I guess add cell. Okay, cell equals terrain, cells, cell index, F. And then I just need to loop through every triangle that's been added here, so int num tries equals cell collider tries length divided by divided by 3. That's because how we store triangles are triplets of integers, and the integers are just the points, so that's pretty simple. And for int t equals 0 less the number of tries. Okay, so now let's see. So first I need to have another function here that if a vertice, or if a triangle references a new vertice, I need to add it to the vert builder and the point to vert map. Okay, so let's see. Get. Okay, yeah, that's fine. So if point to vert map, try get value. So if this returns true, then we can just return vert. That means it already existed in the map. If it did not exist, then we need to first figure out as vector3 and add it to this vert builder, and then add that index to the point to vert map. So vector3 position. Alright, so this part might be a little fun. So it's 0, 1, 2, 3, 4, 5, blah, blah, blah. So basically, we can kind of think of it, if it's the first, or if it's anything but the last row, then it'll be either this corner or this corner. Unless it's the very last in the column, and then it would be this corner for the last one. So there's a couple of discrepancies. I think I might make a separate function for this, because we'll probably want to spin this off into a different class entirely. So get world position. Okay, so I have the database. Oh, I actually do need the battle because I need to know the number of, or the size of the map. Right, I won't create the constructor yet in case I need to change these helper lists. Okay, so if it's in the last row, then we need to do something separate or something different. So if point, or let's actually do this. So column is point. Okay, so I'm trying to find the hex column. Probably. Oops, what's going on? Yeah. So hex column is the point divided by 2, and then modulo. Oh wait, no, that's not right. Okay. Yeah, modulo the number of columns. So battle, map, and the row size is the number of columns. And then the hex row is point. Okay, so basically what I did before was I divided by 2, so I kind of collapse these inwards. Then obviously, okay, for this point, divided by 2 would still give me this row outside here, so that is actually good. So for this, to get the number of rows, I would... Okay, so it's actually a little simpler than the other one. It's just the point index divided by the total number of points in a row, which is the same as the number of hexagons in a row times 2 plus 1. Okay, so let's see. Num point columns is battle board row size times 2 plus 1. Okay, so this is just point divided by number of point columns. Okay, so I think that's right. And if hex column... Oh wait, no, I guess I should do the row first. So if row is less than the number of rows, which... Okay, so int num hex rows. You don't have that already calculated, so I just get the layer size and then divide it by the row size. Okay, and then if hex column is less than battle board row size, let's make this symmetric. Okay, so if it's here... Okay, let's actually have another helper function. Well, I guess it's a... I don't know if I... might as well. Private vector 3 get world position, and then this would be x index and the position corner. Length, and then I need to add, okay, this should be multiplied. And then I need to add the center position, which is hex position from board index to Cartesian. Oh, what happened there? Why is it not showing up? Oh, of course. I must have... Oh, it's using the mod database? Why? Oh, because it's not called database, it's game data. Okay. Okay, so that's fine. Get... Oh, got the D. Get world position. Okay, so the hex index... I guess I can... Oh no, I shouldn't do it right there. So this would be hex column plus hex row times number of hex columns. And then the corner is... Okay, it depends on if the point is even or odd. So if point mod 2 is 0, then we'd have this corner, which is southwest. Otherwise, it's just south. Okay. And then, okay, so if this is equal to the number of hex columns, then we're dealing with this point right here. So this is southeast for the last one. So I'd really want to just do number of hex columns minus 1. Because, yeah, that's right. And then this is just southeast. Alright, and then for this last, if we're at the last row, which is at the top, then it's pretty much the same, except I just do number of hex rows minus 1. And then this is northwest and north. And northeast. Okay, so hopefully this works. We'll have to do some testing, but I mean, unless I got some math wrong. Oh, also this doesn't take the layer into account at all. I forgot about that. So int flat point equals point. Okay. So int num points in layer. Okay, so we actually... Oops, didn't copy it. And num point rows is battle board rows. Well, it's the layer size divided by the row size, and then plus 1. So it's just the number of, I guess it's the number of hex rows. That might be an easier way to do it. Okay, and number of point columns times number of point rows is the number of points in a layer. Okay, and so the flat point is that modulo number of points in a layer. Okay, so instead of returning, returning this. Oh, well, the hex index takes into account the layer already. Although I don't here really. Oh, thanks Zakat Television for hosting me. I really appreciate it. Hey, how are you doing today? We're just finishing up some math, trying to build a mesh for picking a tile with the mouse. Okay, so that'd be the best way. I guess I should just add a layer here. So yeah, int hex layer is okay. Well, the point layer is always the same as the hex layer, so that's kind of good to see. But I guess I can just do point divided by number of points in layer, and that will give me that. And then this flat point is what I need to use for this. What'd you work on today, Zaka? Or stream, I guess I should say. Alright, so yeah, now I can just add this on. Alright, so let me look through here one more time, see if I can catch any stupid mistakes. Number of hexagon columns is the same as the row size. Number of hexagon rows, the same as the layer size divided by the row size. And then the point columns is hex columns times 2 plus 1. So yeah, because there's 2 for every column and then plus this last one. And the number of rows is the same as hexagon rows, except we have this top row up here. Points in layer is just multiplied that. Flat point, then we modulo. And then the hexagon column, okay, we take the flat point and divide it by 2 to collapse these 2 points into 1. And then I just modulo by the number of hex columns. Is that right? No, that's correct. Because, yeah, the number would be 8. So, yeah, if it's above 8, we'd want to loop back down. The hex row, we take the flat point and divide that by the number of point. Oh, that's wrong. Number of point columns. Yeah, because... yeah, that's right. And then the layer is easy. It's just the point divided by points in the layer. Okay, and then we check to see if the hexagon row is less than the number of hex rows. Then we know it's one of these points. Okay, so I think this is all right. Oh yeah, we'll need to do some testing. But anyway, the whole reason we did that was so that we can add this vertice builder, add get world position, point, and okay, and then the point to, oh, I guess I should get the vert index is vert builder count -1. Okay, let's actually do it this way. False. So if this is false, then we'll run this code. And now I just need to add it to that dictionary. So point to vert map. Okay, there we go. And then here, let's see. So vert equals get vert. Okay, let's actually need to do A, B, C. Now that I think about it, do I need to go by triangle or can I just take each triangle point and do it that way? And then we just add that to the try builder. Yeah, because we don't really need to ever collapse any triangles because every triangle, there'll never be any duplicates. And then, so the owner builder, well, the owner builder we actually just copy from the cells as well. So owner builder add range cell dot collider, or what is it? Triangle owners. Okay, so that's cool. So for int c equals 0, c less than terrain cells. Oops. Okay, and then I just need to create the mesh equals new mesh, and then mesh dot vertices. Oh, I don't really want to create a new one, do I? Well, I don't, because I could just reuse it. Let me see. So mesh if terrain dot collider mesh does not equal null. Or let's do the null first. Oops. And okay, so here we'll just clear it and then mesh dot verts equal, or wait, no, we should call set vertices. And then mesh set triangles. What's it not like about that? Oh, submesh. We don't have submeshes, so. Oh. Okay, we only have to clear it if it already exists, so that's fine. And then I gotta set the owners, but that would actually go in the terrain data, not the mesh itself. Okay, and then terrain dot owners clear and terrain try owners add range owner builder. Okay, and now we just clear out all these lists. Okay, and now I just need to create the constructor here. We don't need to get any of those passed in. Okay, so I think this is about it. So yeah, this code is kind of where all the magic happens. We'll deal with that later. Oh, well, if I add it, okay, nothing's gonna actually happen because the dependencies aren't, well, we don't actually create any of the triangles yet, so can't really test it, unfortunately. But okay, I'm glad that I finished it. Okay, maybe before I clear it out, I'm gonna just make a little diagram, or maybe before we finish for today, that will number all the points in a 3x3 grid just so I don't forget how I laid everything out. Okay, so this is point 0. One, two, three, 4, 5, 6. Oops. Okay, I remember this is kind of a pain because you have to click right on the number. Okay, so how about I just duplicate these? I didn't think about that before. Okay, that lines up. Wait, there's one less point here? I didn't. 1, 2, 3, 4, 5, 6. Oh, there is. What is going on here? It's just this one. Okay, so this... Oh, I didn't take this point into account. Only these two. Oh no, okay. Well, I guess I'm glad I figured that out. We can go back. I have the tools for it. 4, 5, 6. So, okay, this has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's kind of annoying. But that's just how it goes. So the first and last rows have a different number than every other row. Now that I counted, I do see that. 14, 15, 16, 17. Four, 25, 6, 7, 8. Okay, so what would be a better way to position these points? Because right now I always use the bottom row first, but well, I guess I still can. It's just for the first row, or for the first point on every column. That's not the first column. I have to use the northeast point. Oh, right, northwest point for the cell below it. That's not too bad. So that would be... Okay, that's kind of annoying because it actually goes in both of these. But it would be... Actually, the logic is about the same. Okay, let's just, okay, throw new, not supported. Take, let's see, take north, west, point, okay, first point on every row except the first. Okay, I guess it changes calculate. Okay, so yeah, I'll see. Oh, I shouldn't forget that. Yeah, so we'll figure that out tomorrow. There might be a better way to organize this. I'm not sure. Yeah, I should have known it. Couldn't be this easy. But anyway, I'm gonna go get a bite to eat and then work on some stuff offline, but I'll be back tomorrow at noon Eastern, so feel free to follow me here on Twitch or on Twitter if you'd like to get notified when I go live. I also have a YouTube channel where I upload all past streams, so you can check out how the game used to be or just see progress. And then a Discord server where you can chat with me anytime. I'd love to have you there. But yeah, I think that's about it. So I'll put links in chat, or you can check out the video description if you're watching on YouTube, and I'll see you tomorrow. Have a great day. Bye-bye.